Welcome to The Explainer. Today, we're taking a seriously fascinating journey deep into the world of food science. We're going to look at how scientists are literally hacking the microscopic structure of a plant seed to unlock some truly incredible properties. It's this wild story of raw potential, stubborn biology, and how a clever combination of modern tech can completely transform an ingredient from the inside out. So get ready because we are diving right into the secret science of creating porous starch using microwaves and ozone. Right off the bat, here is the fundamental puzzle we're trying to solve today. Imagine you've got this tiny, incredibly dense seed. In its natural state, it resists water. It totally doesn't want to dissolve, and it definitely doesn't want to expand. So I want to pose this question directly to you. How do you take a stubborn, rigid little seed and make it soak up water like a highly absorbent sponge, and do it without using any harsh, toxic chemicals? To figure that out, we first need to meet our main character. This is Adlay, scientifically known as Coix lacrymojobi. It's a cereal grain that grows all over the world, and it has this massive hidden superpower. It is absolutely packed with starch. In fact, up to 70% of its dry weight is pure starch. That kind of massive starch content gives it immense potential as a food ingredient, as a thickener or even a carrier for flavors. But there's a huge catch that has basically kept this grain totally underutilized in the food industry. Okay, let's dive into this. We call it the rubber ball problem. On one hand, you have that incredible 70% starch potential. But on the other, native Adlay starch has notoriously low water solubility and a really low absorption capacity. Think about what we actually want: a highly porous, absorbent sponge, right? Well, native Adlay starch acts more like a solid, dense rubber ball. Water just bounces right off it. If you try to use it to thicken a soup or hold on to a flavor, it simply refuses to cooperate. It's kind of like a toddler refusing to eat their vegetables. The starch is just locked away inside this super tight crystalline structure. So how do we crack the code? Well, researchers found out that the answer actually lies in a dual-pronged attack. We're bringing in two scientific interventions, essentially two superhero hacks, to break down that rubber ball and turn it into our super sponge. Those two interventions are microwave heat treatment, or MHT, and ozonation. Let's look at that first hack, microwave heat treatment. When you put Adlay starch through MHT, you're utilizing this awesome phenomenon called dielectric relaxation. Basically, the microwaves cause the polar water molecules inside the starch to spin and vibrate incredibly fast. This rapid friction heats the starch completely from the inside out. As that internal moisture quickly evaporates, high pressure builds up inside the starch granule, and it physically expands and cracks the granule right from the center. We are literally blasting the starch's defenses from the inside. Now for the second hack, ozonation. Ozone is a gas, and it's a tremendously powerful oxidizing agent. When you introduce it to the starch, it acts like the ultimate cleanup crew. It attacks and weakens the starch's tough crystalline structure, carving out these tiny microscopic pores. But honestly, the best part? Unlike traditional chemical acid washes that can leave toxic traces behind, ozone quickly decomposes naturally back into pure oxygen. It leaves zero harmful chemical residue. It is powerful, it's clean, and it's totally environmentally friendly. Now, on their own, each of these treatments improves the starch a little bit. But that brings us to the most exciting question of this entire study. What happens when you unleash both of these powerful forces, microwaves and ozone, on the exact same starch granule? Like, does one ruin the other? Or did they team up to create something entirely new? Let's move to how this builds, because researchers tested multiple combinations to find the exact sweet spot, and they discovered a highly precise winning formula. Step 1. You've got to perfectly adjust the starch moisture to exactly 30%, which gives the microwaves just enough water to work with. Step 2. Apply the microwave heat treatment for exactly 6 minutes on a low setting. Step 3. Follow that up immediately with ozonation for 20 minutes. This precise sequence right here, that is where the magic happens. Now, what's really interesting about this is the visual proof, which is just undeniable. If you look at native untreated starch under an electron microscope, it's smooth and solid, exactly like our rubber ball. But after this combined treatment, you can literally see the craters. The starch granules have been physically blasted open, leaving these deep physical pores all over the surface. It is wild to see. Think about the microscopic teamwork happening here. The microwaves act as the battering ram. They crack the outer defenses and create these initial fissures. Because those cracks now exist, the ozone gas isn't just working on the surface anymore. It can penetrate deeply right into the heart of the granule, oxidizing the starch from within and hollowing it out into this highly porous, incredibly efficient microscopic sponge. The starch is now perfectly primed to absorb. And the data backs this up spectacularly. When researchers tested this dual-modified starch, the swelling volume hit a massive 22.43 milliliters per gram. To put that into perspective for you, that is a 1.24 times increase compared to the native starch. By creating those deep pores and expanding the internal structure, the starch can now swell up dynamically when it's heated in water. And this brilliantly illustrates exactly why the combination is so vital. If you map it out, the untreated native starch has super low swelling. The microwave treatment alone? Yeah, it's better, but not amazing. But when you combine the 6 minutes of microwaves with the ozone, the synergistic effect drives the swelling volume all the way up to that peak of 22.43. The whole is truly, absolutely greater than the sum of its parts. But hey, swelling is only half the battle, right? We also needed to absorb water effectively. And the water absorption capacity hit a peak of 3.31 grams per gram. This totally confirms that the stubborn, water-resistant seed we started with has officially been transformed. The new hydrophilic properties, combined with those deep surface craters, mean water easily rushes in and gets trapped within the granule. Our super sponge is fully operational. So let's tally up the wins for this newly engineered synergistic super ingredient. Compared to all the other methods tested, the combination of 6-minute MHT and ozone give us the highest water absorption capacity, the largest swelling volume, and of course, zero chemical residue. But there is one more massive win here. It achieved the lowest breakdown of viscosity, measuring at 3,779.33 centipoise. In food science terms, a low breakdown viscosity means the starch is incredibly stable. It won't just easily turn into a watery mess when it's subjected to high heat and the heavy shear forces of being stirred into a giant industrial mixer. So the crucial point is, why does all this complex physical-chemical science actually matter outside of a laboratory? Well, it matters because these tiny, deeply porous structures have incredible real-world benefits for the food industry. Because they soak up and hold liquids so incredibly well, they make vastly superior thickeners for things like commercial soups. Plus, those deep microscopic pores are absolutely perfect for advanced encapsulation, meaning we can hide sensitive vitamins, colors, or flavors deep inside the starch, creating highly effective slow-release agents in the foods we eat every single day. We started with an underutilized grain, and using nothing but targeted heat waves and a gas that turns into pure oxygen, completely hacked its cellular structure to create a highly functional, porous super sponge. It leaves us with a pretty thrilling thought, right? If a clever, clean combination of microwaves and ozone can completely unlock the hidden potential of Adlay starch, what other everyday overlooked foods are just waiting to be engineered into tomorrow's super ingredients? Thank you so much for exploring the science of porous starch with me in this explainer, and keep your curiosity hungry.